This was the 17th question of the assignment. First, I tried it with the algebraic function as the first function, but then I realized that when I was taking the derivative of the algebraic function, the the terms were going complex and complex. So I just tried the other way around. Just thought of that ex doesn't trouble us by being a first or the second function, because integration and differentiation both is e raised to power x only. uh, and I realized that I have a way out to integrate this algebraic function. No? By partial fraction, I can easily integrate it. So just tried it out here, and the process went till here. Uh, and at this point, at this point, I got this. Okay, so I distributed this integral to this first term and to this second term. Okay, and it took the form this. Then I was just thinking further how to sort them up. Suddenly I realized that this will this if I solve it up and I don't solve this, this will cancel automatically. Because if I'll choose this as the second function, so I will get natural log of 1 plus x. So and so and in the second term, means in the second term of the formula, I'll get e raised to power x as the derivative, and I'll get this as the natural log of 1 plus x, and there it will cancel. So keeping that in mind, I just let this part as I1 and started sorting it up, and I was right. I got these two terms. Okay, and when I'll substitute it here, um, so this is my negative term, and this is also negative but will become positive by this minus sign, and then they will cancel. So I was correct, and these two things got cancelled up. I need not to integrate them, and I got my solution. And then there was another solution proposed by one of you. Here also, he started the work by substitution, and looks much simpler. And mm, when he sorted it up here, this by the integration by parts, mm, the first term by integration by parts, he got these two terms. Okay, these two, and he need not to sort this one up, they got cancelled up. Okay, so was it by chance? Actually, the questions were planned. So okay, whenever you have the questions like this, okay, at means the things will cancel up because the questions are planned. So, and how the questions are planned, the question are planned based on this theorem. Okay, according to this theorem, if we have our first function as an exponential function, and our second function, not yeah and if we have our second function as fx plus f prime x, then things gets cancel up, and we get this as our this mean things always will cancel, and this will be our final result. Okay, so we should always look for this, means you must analyze your question, is it of this format or not. Okay, we will discuss about that later. First of all, let's see the proof of this. The proof is quite simple. We can integrate the left hand side. Okay, and we can easily reach here. Okay, let's distribute the integral. So here we will have this. So here I sorted up this only. I did not sort up this because I have an intuition that mm, this will get cancelled up, and I'm right also, because this term here will reduce up to ex. And what's the integral of this? Integral of this is this, and here we will have derivative of e raised to power x is this only, and integral of, sorry, I forget to put this, integral of this is this, no? So this will cancel up with this term here, no? And we have answer, a constant of integration can be put, so we have answer this plus this, which is here. Okay, so now you'll be given um, questions well planned, okay, where one function is this and the rest function is expressible in the form fx plus f prime x. Okay, and this can be, how did I get to know? When I was doing it, when I was sorting it out by partial fractions. Okay, so x over 1 plus x square is actually equals to these two fractions here, and this one is actually this, along with the minus sign, this is actually the derivative of this. Okay, so then the thing is this, so when you have this quotient, so you can use this concept, and please add this to your concept map. So your quotient was this, and this can be reduced into equivalent form, this, where this is fx and this is f prime x, so we can say this is fx plus f prime x, no? And thus, by using the theorem, we have the final answer of this as ex into fx, and your fx is 1 over 1 plus x, which in simplified form can be written like this. Okay, and we can also put the constant of integration. Yes, we have to submit the reason for this straightforward answer. And what is the reason? The reason is here, it is this, we have to write this here. So this is the reason. So in the rest question also, whenever you have two functions to integrate, means the product of two functions to be integrated, and one of them is exponential, then you should always look for on the next whether that is expressible in fx plus f prime x format or not. If yes, you can simply use this fact here, uh, and and end up your solution. That's all for this video.